Okay, welcome back, Math 20-3, and welcome to Lesson 1.3, Rate of Change. So what we're going to be getting into now is going to be this graphing stuff. Whoop. So this type of thing that we have down here. I know some of you might not like graphing to begin with, but it's not as bad as you think. So what we're going to be talking about now is really the same thing. When we were talking about slope as being a rise over a run, it's going to be the same. We're still going to have a rise and we're still going to have a run, but now we're going to be just plotting it on an actual graph. So first thing we'll notice is this new equation that we have here. M is equal to y2 minus y1 over x2 minus x1. Don't be too concerned about that if you don't know what that means. What this is really still just saying is that m, slope, right? This is what slope meant from the last videos and lessons. M is equal to rise over run. So when it says y2 minus y1, what it's talking about is points. So hopefully from other courses you can remember how to plot points on a graph. Well, if I plotted this point, let's say up here, the first number is going to be the x value. So I count over to the right. I go, okay, 1, 2, 3, 4. So x would be 4. And I'd count up 1, 2, 3, 4. So the y value would be 4. So this point would be 4 comma 4. Okay, so that's all it's talking about. And this is, if you wanted to over top, you could say this was an x and that was a y, right? That's what each of those would be. Now, if we went down to the bottom point here, that point right there is 0 comma 0, right? The x is 0 and the y is 0. So if I want to use this formula to figure out what the rise and what the run were, really, because the top here is just the rise and the bottom is just the run, let's do that down here. So m is equal to y2. Y2 just means the second y up here, right? The y value, like this one that we had. So that would just be 4 minus 0 and then over. And it was 0 because y1 was 0, right? That was that one down there. They were both 0. So that's just 4 minus 0. And then on the bottom, it's the x values. So that's going to be x2 minus x1. Well, x2 was also 4. That was that one there, right? So that would be 4. And on the bottom, that would be 0. So the slope here would be 4 over 4, right? Because 4 minus 0 is still just 4. Which is also equal to, if you went 4 divided by 4, or just simplified this fraction, that'd be 1 over 1, or just 1. So the slope of this thing is equal to 1. So you don't really, though, like I know some of you might be feeling a little bit like scared that you're going to be having to use this formula all the time. You won't really need to. For the most part, all you ever need to do, if you're figuring out the slope of this thing, oh, one sec. All right, it's working again. Is just as soon as you get like a line like this, like we have in the question, draw a triangle. And it doesn't actually matter where. You could draw a triangle from there to there. Or I could have drawn a triangle from, anywhere here. Could have been from there to there. Doesn't matter where, as long as it's a triangle on there. And then all you're going to do is pretty much count up. So this side is my rise. This side is the bottom is my run. So my rise was 1, 2, 3, 4. My run was 1, 2, 3, 4. So I just say m is equal to 4 over 4, which is m is equal to 1. Okay, hopefully this equation didn't screw you up too bad. I just wanted you to kind of be introduced to that value, like talking about it as y's and x's. All right, so if we look at this one, if a graph falls, and actually, here, one sec. Looking back at this one, I forgot to kind of say one thing. You can see that this is going to also be a positive slope. And what I mean by that is we ended up with positive 1, right, when we figured that out. And that's because we had, this was positive 4, right? 4 was going up, and then positive 4 on the bottom. 4 was going that way. So it was positive 4 divided by positive 4 gave us positive 1. And you can kind of just always remember this too, that if it's going up and to the right, it's going to be a positive slope. The opposite of that now, if it's going down and to the right, that's going to be a negative slope. And the reason for that, so I'm just going to do this one here. If we drop down, just draw a triangle like I was saying, from there to there. Now this is my rise, and my bottom is going to be my run. Well, we've dropped negative 3, right? So if I did this as my formula, we'd have m is equal to rise over run. So m is equal to, and now it dropped 3, right? Like my rise is negative 3, we would say, because it went down 3. So that's going to be negative 3 divided by, and then it went over 1, 2, 3, 4, 5, 6. So negative 3 over 6. Simplifying this fraction, I can see if I went, okay, I can divide the top and bottom of that by 3. My slope would end up being negative 1 over 2. Right? Negative 3 over 6 is the same as negative 1 over 2. And you can see I have a negative slope. Okay, so for example 1, it says, consider each of the following graphs, so the slope's positive or negative. Well, this is pretty easy to tell, right? Up and to the right is going to be positive. So you can just put a P up there if you want to say it's positive. This one, I know that's positive too, up and to the right. And I can tell from looking at C, that one's got to be negative. It's like sloping down to the right, so that's going to be negative. Okay, and then it says, calculate each slope as a fraction. I should zoom in a bit. Right, so like I said, just make a triangle. I would just go right from there. Oh, too far. Up to that point probably, and say, okay, it had a run of 4. It had a rise of 3. So apparently if I went, m is equal to rise over run, then slope is equal to, my rise was 3, my run was 4. That's my answer, 3 over 4. Okay, the next one here, I'll kind of help you set up. Just draw a triangle. You've got a run of 3. You've got a rise of 1, 2, 3, 4, 5. And I'll let you guys finish that one. So what is the slope of that one? One thing to notice though too, what I'm able to do here is because our graphs go up by 1, right? You can see that like my grids go up, like this is 1, this is 2, 3, 4, 5. It makes it really easy. Now all you have to do is count the boxes. But let's say if this was on my grid, this was like 10 here or something, and this was 20 there, you couldn't get away with this because then every box that you count would actually count as 2. But don't get too confused about that yet. They're all pretty straightforward grids for now, but I just wanted you to be aware of that as we go on. All right, I'm also going to let you guys do C, but just be aware when you make your triangle that this one going down, it's going down. What does that mean? That means it's going to be negative, right? So when you figure out your slope, your answer should be negative. So make a triangle out of that. Oh, not negative 3. It'll be negative something else, but it'll be negative. Okay, and if you guys were really savvy, you might be able to turn to the next page and see that the answers are there. I'd still like you to show it on your graph though. Draw a triangle. It's easier than this this method I find with like the y2 minus y1. That'll work too. You put your numbers in, that's fine. But I sure found using this triangle thing a lot easier when we did it, right? So make sure you're able to do that because that's not going to go away. We're going to keep doing this. All right. Build your skills. Let's see this one. All right. So it says calculate the slope of the 2 lines on the graph. Which is steeper? Okay. Just using like your common sense, which one would you think is steeper? Which one would you slide down faster? Well, that'd be this one, right? That's steeper, right? It's going up quicker. So calculate the slope of the 2 lines. So what I would do, get a different color pen maybe. Just draw your triangles. So let's do this one first. So we'll go from there to there. And it wouldn't matter. Remember, the slope here is just a ratio of rise to run. I could have made my line go from there to there. I also could have made my line go from here to there. It actually doesn't matter. You should end up with the same number. The ratio will be the same. As soon as you divide the rise over the run, the number would be the same. The slope would be the same. So it doesn't matter there. So you can go ahead and do that. I'll let you guys figure out what the slopes are for these 2 things. On the second one, you might go like this, or any triangle on that thing. It doesn't actually matter. So if you guys figure out what those are, I will give you a hand on this one because I know this one's a little bit misleading. It says calculate the slopes of the 2 lines on the graph. So the 2 lines here, how would you figure out the slope of a flat line? So we had a slope before, right? We were able to figure out the rise and the run. But now this thing is just sitting flat. So technically, this has a rise of 0, right? It doesn't have any rise. This part of my triangle doesn't exist. So this has a rise of 0 and a run of, well, for L1, that's 1, 2, 3, 4, 5, 6, 7. But it doesn't really matter because if you went for L1 there, for line 1, we were figuring out the slope, I'd say, okay, well, m is equal to rise over run, but my rise is 0. So 0 divided by, what did they say that was? 1, 2, 3, 4, 5, 6, 7. 0 divided by 7? Well, 0 divided by anything is just 0. So that's just equal to 0. And you can see that, right? That makes sense. The slope of this thing is 0. It's not sloped. It's totally flat. All right, now if we look at this straight up and down line, though, it's kind of a different story. So now this time, we have a rise. We have a rise of 1, 2, 3, 4, 5, 6, 7. But what's our run? We don't have any run. There's no run at all. The run this time is 0. So if we want to figure out L2, that'd be rise over run. And this time we have a rise of 7 and a run of 0. If you go on your calculator and you go 7 divided by 0, it's going to say undefined or error or something like that. That's because you can't divide a number by 0. It doesn't actually work. So this is actually, you could think about it as being like infinitely sloped, or you could just say undefined. Like UND is sometimes how we write undefined. So yeah, you can't really say this thing even has a slope. Or you could say it has an infinite slope. It's kind of hard to even think about it. All right, moving on. Okay, so 3 here says, on the graph below, draw a solid line that passes through point A and has a slope of 6 over 5. And I'll zoom in a bit. All right. So thinking about A here first, though, I just want you to kind of look at, so again, let's start off with let's write A, and our formula is m is equal to rise over run. Well, it says it has a slope of 6 over 5, so m is equal to 6 over 5. Just remember what these things mean. The 6 was the rise, and the 5 was the run. So all I got to make sure is that when I draw my line, it has to go up 6 and over 5. So what I would do is start right at our point, and then I'm going to do the run first just to make the triangle kind of look more like we're used to. But I'd count over 5. So, 1, 2, 3, 4, 5. So maybe it's going to go from there to there. And the run part of it, maybe I'll make that a different color. The run part of it's going to go up 6. So that's to rise 6. So that's 1, 2, 3, 4, 5, 6. So rise and run, all I got to do now is just connect the line. So from that point there, back down through my graph, that's my line. And you should use a straight edge when you guys are doing this too. So get a ruler and do that properly. It's just kind of hard with, actually, you know what? I can do that on here. I'm going to do it. Kind of like that. Okay, you get the idea anyway. Oh, I forgot I had another question on there. It says a dotted line that passes through point A that has a slope of negative 3 over 2. So remember, the 3, that's the rise. The 2, that's the run. And it's negative, so it's going down. So it just means it's going to be going down 3 and over 2. So run. Yeah, so hopefully you kind of see that. So again, if we just, sorry, I threw my pen at the screen. If we just started at our point A there, and we say, okay, it has to have a run of 2. So I'm going to go over 2. Let's use that one. So I'm going to go over 2. And then it has a run of 3, or sorry, a rise of 3, but it's negative. That negative is kind of like attached to the top number. Think about it. It's probably the easiest way to think about it. So negative 3, that means it has to go down 3. So I'm going to go 1, 2, 3. Okay, and then I don't really know how to make a dotted line on my thing, so we are going to just make a purple line. There. And it would, Oh, awful. All right, take two. Anyway, my straight lines aren't working out here. I don't know why they're doing that. Pretend that was straight. So then that would be your line like that, right? And you can also just make sure you know that you'd usually write that line right through that dot. So to keep on extending through all the way to the end of the graph. Okay, so those are our two lines like that in the end. All right. Okay, new skill here. We're going to be talking about, well, still slope. It's still slope, but we're going to be talking about it as a rate of change now. So kind of giving it some context. So pretend that you were to travel in a car at a constant speed of 50 kilometers an hour for some time. You will have traveled 50 kilometers in 1 hour, 100 kilometers in 2 hours, 150 in 3, and so on. You travel at 75 kilometers, you go 75 kilometers in 1 hour, 150 in 2, and so on. So if we plotted this, it would look something like this, right? Where we've got distance up the side, right? 50, 100, 150, and then time going across the bottom. And distance is in kilometers, time is in hours. If you figure out the slope of any of these 2 points, so let's say I figured out, I drew a triangle from there to there, or I drew a triangle from like there to there, doesn't matter, right? The slope, it would still be the same. The ratio there would still be the same. So if you did that though, and let's make sure that we're doing this right now. So the bottom here, if I figured out the slope of this thing, this would be 2. And then how many does this go up? Well, what you have to do though is look at your side here, like what we're going up by. You can't just count up and go, okay, well, this is 4 because there's 4 boxes. This is actually going to be, well, 150 is the top and 50 is the bottom. So 150 minus 50, this is 100. So 100 in kilometers you could even put for your units. Maybe hours down, 2 hours in the bottom. Hopefully that made sense. You were able to kind of see that. So if you figured out the slope here, you'd have m is equal to 100 kilometers. And then the run would be 2 hours. If I divide these things, I'd have m is equal to 100 divided by 2 is 50. And then you just keep your units. I've got kilometers per hour. So speed in this case is the slope. The slope of this graph, this distance time graph, is the speed that you're going, 50 kilometers an hour. Hopefully that kind of made sense. I hope it did. A few terms that we're going to be going through now is so rate of change. Rate of change really is something like a speed. So the rate at which one variable changes compared to another. So when we're talking about the rate at which distance changes as time changes, that's what a rate means. How does one change compared to another? The next one is going to be independent variable. Independent variable is going to be the variable that doesn't really depend on anything, right? In this case, it's going to be time pretty much all the time. So you can think about it this way: the time just keeps on ticking, right? It's going to go 1 second, 2, 3, 4, and it's going to keep on going, right? Dependent variable is going to be kind of what comes out. So if you're going 50 kilometers an hour during some time, how far do you go? So that's the dependent variable is like the thing that comes out of it. So it's what depends on the time, or what depends on the independent variable. So if you were going to make a graph or a formula of these 2 lines, you can make a formula of this line, you can make a formula of that line. The way it would look is the first one would be D1 is equal to 50 times T. And the 50 was just the slope. So we figured out the slope was 50 kilometers an hour. And that's it. So if I wanted to figure out how far I went at any point in that graph, let's say I wanted to figure out how far I went after 2 seconds. Well then, actually let's do another time. Let's say I wanted to figure out how far I was going after 4 seconds. Well then I would just go D is equal to 50 times 4. So after 4 seconds I'd be going 200 meters or kilometers. Or I would have went 200 kilometers. So that's kind of what that means. And then the next D2, again, that's just your slope or your velocity for the second line. Okay, so for the sake of time, I'm going to let you guys look through the following example. So there's that, and it kind of goes through pretty much exactly how to do it. And I'm going to help you through this skill builder one. So let's go number 4 here. It says Reggie is starting to practice for a marathon. If he walked 3 kilometers in 30 minutes, what is his average rate in kilometers per hour? All right, so 3 kilometers in 30 minutes. Well, if we had a graph of this thing, like before. Okay, so yeah, here's a little graph here. And that'd be 2, and that'd be 1, that'd be 0. I've got distance going up the side here. And then I had my bottom. Well, would it be in minutes or would it be in hours? Well, my answer is going to be in kilometers per hour. So what I'd probably want to do is have this thing in hours. So this would be like 1 hour, 2 hours. And so far, this thing goes up to 3 every, well, 30 minutes. How many hours would 30 minutes be? How many hours is half of an hour? It's half of an hour, right? So this thing would go up to there in a half of an hour at midway between one. So what you could do is just draw a line from there to there. So what we've really got here is that they're going to be going 3 every 0.5. So if you want to figure this out, this would be a rise of 3 and a run of 0.5. So m would be equal to 3 over 0.5. So if you put that in your calculator or you just know how to do it, that would be 6. So 6 kilometers per hour. Or maybe you could just do this one in your head. You could see that, okay, if he walks 3 kilometers in 30 minutes, how many kilometers would he walk in double that? If I doubled 30 minutes, well, he would walk 6 kilometers. So we'd be going 6 kilometers per hour. So I just wanted to show you kind of both ways of thinking about that. So for B here, though, it says, what is the independent variable? So the independent variable is the one that doesn't depend on anything else. Well, that's time. Time just keeps on ticking. So that's going to be time. If he does not change his pace, how long will it take him to walk a 36-kilometer marathon? Okay, so we know that m is equal to rise over run, right? In this case, we know m. We just figured it out. It's 6. So I'm just going to write it over here. This is 6 kilometers per hour is equal to, well, so remember that this slope would keep on going even up here. So if we had this as our slope, right, it would keep on going at this pace, right? And we're saying after 36-kilometer marathon, how much will his time be, right? So really what we're saying is if we go up 36 for the rise, what will the run be? That's really what we're saying here, right? So I know that m is equal to 6. I know that my rise is now going to be 36 kilometers. Oh. And it's saying, okay, what's my run? What's my time, right? We can call it x or we can call it t if you wanted to. So then we just have to solve for t. So some of you guys, I've shown you a little trick that if you put this over 1, then you can just end up cross multiplying to find that, to figure that out. Yeah. So I'll let you guys go ahead and figure out what t is. Okay, number 5. Janita's car needs repairing and she borrows $600 from her brother to pay the bill. She repays her brother $40 a week. All right, write an equation that shows the relationship between how much she owes her brother and how much she pays each week. So if we started off, we have to kind of think about it. So if we talk about how much she owes, we'll call that maybe D for debt. I didn't want to do O because it looks like a 0. So I go like D for debt is equal to, well, whatever it's equal to, it's got to start at 600 because that's how much she borrowed, right? So it's going to be $600. And then we're going to subtract off $40 each week. So it'd be $600 minus 40, and then the weeks change, right? Every week it's going to be like, week 1, week 2, week 3, week 4. So instead of that, we just write W, or week, or maybe time. Let's do time. Let's go T. Okay, so that's going to be our formula. Start off with $600 and then subtract $40 every week. All right, so if we graphed this now, so we think about like debt on this side, like I said. This is really just money, though, we're thinking about. And then time on the bottom, and we're going to go in weeks. What we want to do going up the left side is make sure that we get to 600 at a decent rate. So probably the easiest way is just to go up by 100. Actually, you know what? Let's go up by 50 for each one. That'll kind of make it, we'll use the whole graph. So if every 2 was 100, so this would be like $100. The next one would be $200, $300, $400, $500, and $600. Okay. And our debt, I guess I should put like in dollars. That's what we're talking about here. Okay, so I'm just going to write my formula here so you guys kind of see it too. And then on the bottom, let's just go up by ones. So this would be like 1 week, 2, 3, 4, 5, 6. Okay, up to 15. Hopefully that's enough. So now, really, we're just going to plot some points. So the first point that I want to figure out maybe is like where this graph starts. So what if we said at week 0? So at the very first week. Well, what we're really saying is that this t is equal to 0 then. So what we do is go d is equal to 600 minus 40 times 0. Well, that would be 40, like 40 times 0 is 0, right? So this is just d is equal to 600. So our first point is right up here. It's going to start at 600, which makes sense. She got a $600 loan. It makes sense that's where she started, right? Okay, at week, and then we don't need to do every single one of these, but let's just do it at maybe 10. So if we went at week 10, then we're just going to put a 10 in place of here now. So let's do another one. I go d is equal to 600 minus 40 times 10. So now d is going to be equal to 600 minus 40 times 10. That's 400. So then d is equal to 600 minus 400. That's 200. All right, so now we know that d is going to be 200 when t is equal to 10. So if I went up at 10 to 200, that'd be right there. And then that's pretty much all we need. We got 2 lines. We can just connect the dots here now and just go right on through. So if I'm just going to grab a straight line, hopefully it works this time. It did. Okay. Oh, kind of anyway. There we go. I'm going to go right down to the bottom to extend it through that last point, if this would work. Come on. Okay, something like that. A little bit off, but you get the idea. So then that's going to be our relationship, right? So it looks like it's going to take 15 weeks to completely get our debt down to 0, right? It gets to 0 right there. So it's going to take 15 weeks. Now it says, what is the slope of the line and what does it represent? Well, the slope of this line, I can tell right from here, it's 40. If you looked anywhere on here, if I drew a triangle, let's say using the whole thing, like if I went 600 for a rise, or negative 600 because it's going down, and then 15. So 600. So if we were going to go rise, the slope is equal to rise over run. So go down here. M is equal to rise over run. Well, if I did the whole triangle, then that would be negative 600 over 15, which is equal to 40, or negative 40, I should say. And it wouldn't matter if I would have grabbed this point like from here and went down to there. You should also get 40. No matter what triangle you take here, it would end up giving you the same slope. So if I looked at this side here, that's 200, right? 200 to 400. And then the bottom, this is from 5 till 10, so this is 5. So if I go, so 200 divided by 5, my rise over my run, that's still 40. So you should get the same slope no matter where you look at it. Okay. Okay, so I'm actually going to end that video there. I'd like you guys to do number 6 on your own. Just to give you a heads up, what you're going to have to do to figure out 12% commission on these numbers. So how do you figure out a percent of a number? So give you a hint, you need to change it to a decimal first. So if you need help with that, come find me or your teacher. Yeah, so make sure you do that. The next part, up to D. And then I'm going to start the next video after that. So I'll start the next lesson in here. So that's going to be that video.